Okay. Okay, this was the example. Okay, and I will solve it in the notebook so you have it with you later on. So we have a 6-lane freeway. It has a right side off ramp, ideal geometry, so lane width, shoulder width, reductance, everything is as per what we want. Okay, what we call as the base conditions. Level terrain, 70 miles per hour, free flow speed is given. Okay, so the freeway. The ramp free flow speed is given. Okay. Deceleration lane given. Freeway main line flow is given. Off ramp flow is given. It has an upstream on ramp half a mile. Okay, and the flow rate on that ramp is also given. These values are yeah, it's not mentioned flow rate, so it's volume. Okay, it's volume. And all traffic streams have 9% trucks, and peak hour factor is given. You have to find out the density, speed, capacity, and other service at the ramp influence area. RIA means ramp influence area, the outer lane, and for the overall cross section. So ramp influence area means what? What is the ramp influence area?
The distance after the merging in the merging area or in the divergent area where the influence happens.
Okay, and how many lanes are there in that area?
2 lanes, the first two lanes.
The first 2 lanes, yeah. Now, which type of area is it? Which type of segment is it? Is it a merge segment or a diverge segment?
Diverge.
Diverge, because it's an off ramp, so it's a diverge area. Okay, let me put it over here. Okay, so we start with the calculation of where is it? The flow rates. Okay, we need the flow rates. So now all these values are flow rates. Okay, the V, all these V's are flow rates. Okay, so we must convert all the volumes which are given to flow rates by using this equation. Okay, so first thing we need to peak hour factor is given. The first thing we need to find out is the heavy vehicle adjustment factor. The heavy vehicle adjustment factor. We have 9% trucks. Let me get to the equation of heavy vehicle adjustment factor. Okay, so these are the this is the equation for heavy vehicle adjustment factor, and they have given us level terrain. So level terrain means ET will be 2. Okay, equivalency factor will be 2. So percentage of trucks 9%. Give me the value of FHV. So if I want to write FHV here, 1 divided by 1 plus 0.09 into 2 minus 1. Okay, how much is this?
$0.92.
This is the same for all the flows. Okay, it is same for all the flows. So we will convert the flow for the freeway, the flow for the off ramp, and the flow for the upstream on ramp, all of them to flow rate. Okay, using the FHV and the peak hour factor. Okay, so the flow for the freeway, it will be 4850 divided by 0.93 to 0.92. Yes, how much is it?
Five, 6, 8, 4.
5, 6,
8, 4.
8, 4, and the units are?
Vehicle per hour.
No.
Passenger car per hour.
Passenger car. Okay. Okay, then for the ramp, the factors will remain the same, but the flow is how much? 800. So how much will it be?
937.
937 the cars per hour, and for the on ramp, it has 900. Let me look at what notation they are using for it. Where is it? We are, and we don't have any notation for it here. Okay, they are using VD, so I will use VA then. Right, notation VU. Yeah, VU. Okay, how much is it?
1055.
Passenger cars per hour. Okay. Now, so then we have to find out the value of PFT, so that we can find out the flow rate in the adjacent two lanes. Okay. So we have a 6-lane freeway. So we are looking at this option. Okay. It's a diverge area. We are looking for PFD, and this option. So we have 3 possible equations. Okay. So from these, which equation should we select? We'll come to this table. Okay. So we have an upstream on ramp. Upstream on ramp, no off ramp. Okay, so we are in this condition. Okay, now first of all, I will check VU upon LUP. Okay, the flow rate upon the distance to the off the on ramp, the upstream on ramp. If it is less than equal to 0.2, I will use equation 5.35. Okay, so let me check first of all this. So how much is this? VU upon LU. So VU is 1055 and LU is half a mile. So obviously, the equation, right? VU upon LUP. Yeah. Obviously, it will be more than 0.2, right? There is no way it can be less than or equal to 0.2, right? But for the sake of just writing the value, how much is it? It will double, right? 2000 110, right? So we do not, so this condition is not fulfilled, so 5.35 we will not use it. Now for the other conditions, whether I should use 5.35 or 5.36, then I should check for LEQ. Okay, so distance D is given, I should calculate LEQ. So these are the values for LEQ. This is for upstream on ramp. This is for upstream on ramp. So VU is what you have calculated, 1055. The freeway flow rate is 5684. Okay, let me go here. Okay. So you have VU, you have VF, we have VR. Give me the value of LEQ now.
Eight zero
Doc-
Yeah,
8 3.
Doctor, is it on ramp? Because in the question it's written off ramp.
No, on ramp, upstream on ramp, right? The upstream on ramp.
Okay, okay.
So this is to the upstream or downstream ramp which you have, okay? Not the ramp of the diverge area, not the ramp of the diverge area. Okay. So LEQ is 8083 feet, right? It's 8083 feet. Now I think these values are in feet, okay? Anyway, so LEQ is and how many? So if I calculate this in feet, so this should be in feet then. Okay, this should be in feet because miles dividing by miles doesn't make any sense. So I should convert the distance to feet. So 0.5. How many feet are there in 1 mile? Anybody knows? How many feet in 1 mile?
5280.
5280. So 5280 means this is how much? 2640, right?
Yeah.
Okay, and if I do this with 2640,
0.4.
0.4. Okay, this now is making sense. Okay. In any case, it was more than 0.2. Okay, now LEQ is more than the distance which is given, right? LEQ is more than distance which is given. So I'll come back here. If LEQ is more than the distance, then I will use equation 5.36. The equation 5.36 is this one. Okay. Now, just a question. When I'm writing in the notebook, you can see the notebook, right? Like now the changes which I'm making right now, you can see them, right?
Yes, doctor, yes.
Okay. So VF is 5684. So now we are looking to calculate PFD. Okay. So I will write down the equation 0.717 minus how many zeros are there? 1, 2, 3, 4. Okay. Minus 0.000039 into 5684 plus 0.604 into this ratio which you have just calculated, right? VU upon LUP. So it was 0.4 exactly, or 0.4 something.
0.399.
0.39. Okay. Okay. So how much is it?
Seven three six.
736 or 0.736?
0.736.
0.736 or 0.74, right? Okay, so now we can calculate the proportion of traffic in the two adjacent lanes. So it will be V12 diverge and VF, which is 5684 multiplied by 0.74. Okay, how much is it?
Four one eight
4187.
seven.
Okay, and the units are passenger cars per hour. Okay. Then there was a check. Okay, there were two checks actually. One was that the volume in the third lane should not be more than 2700. The volume in the third lane should not be more than 2700. So how much is the volume in the third lane? Let me call it V outer, because they call it V outer. So how much is the volume in the third lane? If this is 4187 and that one was 5684. So 5684 minus 4187. How much was it? How much is it?
1497.
1497. So we pass this check. Obviously it is one lane, so per lane. And then there was another check that the ratio between the two volumes, per lane volumes, okay? Ratio between the per lane volume. So give me the per lane value for this. They did not give any notation for that. So let me just call it V12 diverge per lane. 4187 divided by 2. How much is it?
2094.
2094 passenger cars per hour per lane. Okay, and the ratio, if you take the ratio 2094 upon 1497, how much is it? No, sorry. I made a mistake, sorry. This is the equation for diverge. This is the equation for diverge. I used the wrong equation. I use this equation. So this one should not be from this value. So we have 800 for the ramp. So 800 plus this minus 800. Okay, so how much is this now? It was a mistake. Sorry. How much is this?
4414.
4414. Okay, and then how much is this?
1270.
270. And how much is this?
2207.
7. Okay, now you calculate the ratio. 07 divided by 1270.
1.7.
1.7. Okay, so it is more than 1.5, right? It is more than 1.5. So I have to this to calculate the to adjust the flow to adjust the flow rate for the adjacent lanes. Okay, so it will be VF upon 1.75. Okay, because the ratio should have been should have been 1.5 or less. Okay, so if it is not, so obviously I will adjust it. So VF upon 1.75 will give me the actual flow in the adjacent lanes. Okay, so we will call it adjusted. We are calling it adjusted flow. So the freeway flow is 5684 divided by 1.75. How much is it?
3248.
3248. Okay. And then what about this condition then? How much flow rate is left in the outer lane? So 5684 minus 3248. How much will you get?
243.
247.
36.
2436. Okay. Passenger cars per hour per lane. Okay, so the limit was 2700. No problem. Okay, if it is still less than 2700, so we don't have any problem. Okay. So first of all, you calculated the PFD factor, okay, and you calculated how much volume or flow rate should be there in the adjacent two lanes, and then you applied the conditions. One of the condition was not fulfilling, so you adjusted the flow rate in the adjacent lanes, and you know, and yeah, so you fulfill the other condition as well. Okay, so both conditions are not fulfilled. Then there were capacity checks. Okay, or basically you are finding out the capacities here. So because they asked for it in the question as well. Okay, so the capacity of the ramp, they are saying calculate the capacity as well. So since we are at the step where we are looking at the capacities, okay, so now we can compare it with the capacity as well. So we have the ramp is at a speed of how much? 35 miles per hour. The ramp speed is 35 and the speed of the freeway is 70. Okay, so the ramp capacity is this one. Okay, so the capacity of the ramp is 2000. The capacity of the ramp is 2000. Okay, so call it CR. Sorry. Cars per hour per lane. Then we have the capacity of the freeway. Let me call it CF. Okay, so we have this speed. So it is 2400. 2400 passenger cars per hour per lane. Then capacity of the ramp influence area, the two adjacent lanes you have, they are calling it V2 or V12. So we have a diverge area, so it is not per lane. You can see here it is not per lane. Okay, it is 4400. Let me just make it bigger. So this is 2400. This is the ramp 2000. Okay, and this is the capacity of the two adjacent lanes, the influence area. Okay, so it is 4400. 4400 cars per hour. That's it. Okay. So our flow rate is less than this, right? Our flow rate is less than this. See here, 3248. So we don't have level of service F. We don't have level of service F. Okay, so we can proceed with finding out the other parameters. Okay. So we have this equation for the equation in the table. Let me put it here. Okay, so first thing we need to calculate is the density. Okay, so you have the equation for density here. So give me the density of the diverge area. V12 is what you calculated in the end. Okay, the last value, the adjusted value, 3248. And LD is the length of the deceleration lane. Length of the deceleration lane is given here as, where is it? 950 feet. 950 feet. Okay. So D diverge to 4.252 plus 0.0086 V12, which is 3248 minus 0.000950. Okay, how much is it?
$24.
24. What are the units? You calculate density, right? So what are the units here?
Passenger cars per mile.
Yeah, passenger cars per mile per day. Okay. Then you look at this table. It's 24, so it's here. So level of service is C. This is the level of service in the ramp influence area. In the ramp influence area. Okay. Now we need to calculate the level of service and the other things, I think, for the other areas as well, right? Ramp influence area, the outer lane, and for the overall cross section. Okay. So let me come here. So we already have this value, right? VOA, we already have it, which is this value. Where is it? I wrote it somewhere, right? This one. Okay, and I don't have to divide by number of outer lanes because outer lanes is 1, right? Number of outer lanes is only 1. Okay, so this is VOA then. So VOA, we already have it. Okay, and we will use this equation okay, this is for calculating SR, and this one, and this is S0. So speed adjustment factors, do we have any speed adjustment factors? So speed is adjusted. Again, if you go back to the discussion of the freeway segment, the speed is adjusted for weather conditions, for incidents, and for work zones. Okay, not for incidents, sorry, not for incidents. It is adjusted for weather conditions, driver population, and work zone. These things are not given. These things are not given. Okay, so it means that the speed adjustment factor will be taken as 1. Okay, if any of these conditions is given, you go back and you calculate the speed adjustment factor from the basic freeway segment, for the basic freeway segment, or any of these conditions not given. So a speed adjustment factor in this case is 1. Okay, so first of all I will calculate S0. Then S0 is this one. Should I take this whole table? Let me put it somewhere. You don't need it. Okay. So 1.097, free flow speed is 70. Okay, so how much is it? S0?
$76.8.
76.8 miles per hour, and No, sorry. VOA. If VOA is less than 1,000, then we will use this. If VOA is less than 1,000, then we will use it. If VOA is more than 1,000, which is the case in our scenario, so we will not use this equation. Okay, we will be using the other equation 1.097 into 70 minus 0.0039 VOA minus 1,000. So VOA is 2436 minus 1,000. Okay, how much is it?
71.2.
71.2. Okay, so this is S naught, and I already have the flow rate for the outer lane, which is 2436. So density, let me call it D naught. Density in the outer lane will be the flow rate, which is 2436 divided by 71.2. How much is it?
34.2.
34.2 miles per hour.
Doctor,
Okay.
this is density, right?
This is density.
So it's not passenger car per
So,
mile.
yeah,
point?
passenger cars per cars per mile per lane. Okay. Then SR. Or before SR, we need to calculate DS. DS. So DS is 0.883 plus how many zeros are there? 1, 2, 3, 4. VR, which is how much? 937. 937. Okay, minus 0.013 free flow speed of the ramp, which is 35. And this is multiplied by the speed adjustment factor, which is 1. Okay. So how much is this?
0.512.
0.512. Okay, the units are not given. I'm not sure about it. Okay, so I'll just leave
And
it.
doctor, there's a typo. It's 0.013, not 12. In the last term.
Okay. Thank you. Okay. So we have free flow speed and fluidity speed adjustment factor. So it is just simply 70 minus 70 minus 42 into the factor which you calculated.
$55.7.
55.7 miles per hour. Okay. So now I calculate the level of service for the did I calculate the level of service for the outer lane? I did not. So I should calculate the level of service for the outer lane as well. I have the density, which is 34.2. So if I come here, density of 34.2 means your level of service D. See here, level of service D. So for the outer lane, the level of service is D. There's only one lane. Outer lane is only one. Okay. Now I will calculate the aggregate speed for the diverge area. This is speed. Okay. Now I'll put it at the side. Don't need it. Okay.
Doctor, what is DS?
DS, I'm not sure. This is a parameter in the equation.
Okay.
Yeah. So we are just using this equation, okay? The second one, V12 is what we know, okay, which is the adjusted flow 3248. Let me crop it. Book is a good tool, but it's very slow. Okay, so we have V12, which is 3248. We have VOA, which is in the outer lane, and N naught will be 1. Number of outer lanes, 1. So VOA is 2436. Yeah, okay, so we have it now. So V12 is 3248, this value. Okay. VOA, the flow rate in the outer lane, 2436. Okay. N naught, 1, number of outer lanes, 1. V12, as I said, 3248. SR, you just calculated 55.7. And VOA, N naught will be 1, VOA 2436. S naught, the speed you calculate for the outer lane, 71.2 miles per hour. Okay, so give me the speed here. And then for the density, you will take the total flow, which is 5684 divided by S.
$61.4.
How much? 61.4. And the density will be
92.5.
92.5. Sorry, we need to convert it to per lane. Flow per lane, we need flow per lane. So VF per lane 5684 divided by 3 lanes. How much?
1895.
1895. Okay, it will be passenger cars per hour per lane now. And how much you get here now? 1831. Passenger cars per mile per lane. And if you go to this table, I think the level of service will be D again. The overall level of service will be D. 31 is here, see, so it's D. level of service is D in the segment. This is for the overall segment. Okay, now all the three lanes together in the complete in one direction, in this particular direction, the level of service is D. Okay, so in the two adjacent lanes, the level of service was C. Okay, let me check. I think we did not make any mistake here. Okay, so the level of service is C, but in the other lane, the level of service D, and because of that, the complete level of service is also D. So there is more flow in the other lane. Basically, the outer lane has more flow than the two adjacent lanes. Okay. Now, one important thing here, if you go to the table of density, you will see more than 35 is E, but there is no value given for F here. Okay, so from 35 onwards, how much is E and then how much will be F? That will come from the capacities. That will come from the capacities. Okay, so I already told you the checks for the capacity. If it's a merge area, then the flow rate which is going towards the ramp should not be more than the capacity of the ramp, the per lane flow rate. Okay, and again you are checking per lane. Capacities are given per lane. Okay, so there are three capacities: one for the freeway segment itself, one for the ramp, and the other one for the two adjacent lanes. So there are three capacities given. If you go over any of them, then you have level of service F. Okay, if your the flow rate which you have calculated is more than the capacity of the ramp, okay, then you will have the per lane capacity, okay, and the per lane flow rate. So you match them. If it is more than the capacity, you have level of service F. If you have exceeded the capacity of the freeway segment, you have level of service F. So I'm talking about these tables. Okay. So if you go over the per lane capacity of the ramp, or go over per lane capacity of the freeway, or go over the maximum flow rate in the two adjacent lanes, then you have level of surface F. Okay, so then you don't have to calculate the density in these things. Okay, without calculating density, you can say level of service is F. Okay, and that's it. Okay. Okay, I will stop here. Tomorrow we will do the weaving segment. Okay, so it's again a part of the freeway. Okay, but we will do it tomorrow, inshallah. So now we'll go for the attendance.